Bismillah ar-Rahman ar-Rahim. Okay, inshallah, this is the rest of the video tutorial for worksheet number 1, in which we will discuss the 3 problems taken from the MIT open course of course, on physics 2. So let's look at the problems one by one. And if we look at the first problem, where he's asking you to calculate, I'm just going to do part A, and part B will be very similar. So you have 3 charges which are located in the corner of an equilateral triangle, so that means these sides are the same. As shown, he wants you to calculate the force on the 9, so on Q3. I call them for simplicity, I call this Q1, I call this Q2 and Q3. So the net force on Q3, it will be F1 on 3 plus F2 on 3, and these are as vectors. So I have to find the magnitude of this and the 2 components of it, X and Y, and the magnitude of this, and of course I have to find the X and Y components for F2 on 3. Okay, so let's start. So we'll use this formula, the Coulomb's law formula, which says that the force, for example, 1 on 3 will be KQ1, Q3, and the distance over the distance between them squared. And there is an r hat here, and the r hat, as said, will be used for the direction. So in this case, it's 2-dimensional. So get the cosine for the x component and sine for the y component. Or the magnitude, which is simply the magnitude, and this would be simply equal to 1. The magnitude of the r hat vector, be it I hat or j hat, its magnitude is always 1, as we have discussed before. So we'll start with F13, with F1 on 3, so this guy on that. So because this is positive and this is positive, so F13 will be away and along the line connecting the 2 charges as usual, and it will have an X component and a Y component. And the X component, this is the angle that we'll be looking at. So this is the angle that we'll be looking at, theta, and in this case theta is the same as this angle here, which is 60. So that means F1 3x x will be simply F1 3 cosine theta, cosine 60, and F1 3y will be F1 3 sine 60. So again, I'm just putting in the cosine and sine, the I hat and j hat, and this is the x component of the force, and this is the y component of the force. If I put in the numbers, actually not the numbers, but the everything, K is known, Q1 is given, Q3 is also given, 9 microcoulombs and 3 coulombs, and the angle theta is 60. If I put these numbers in, I get the magnitude, and so I can substitute these numbers in here, and I can get the x hat and the y hat components. Similarly, I can look at 2 on 3, the black one, 2 on 3. Remember, this is negative, so this will be an attractive force. It will be this way, and again, it will have an x component in this direction, in the positive direction, positive I hat direction, and the negative, the F2, 3y, will be in the negative j hat direction. If I put in the cosine and sine, I just put the minus here because I know it's down. Right? And you can work that out by looking at the negative of the angle, but you don't need to do that if you're comfortable with that. Again, I use the given information Q2 for Q2, Q3, and the angle again is 60. And once I do that, then all I have to do is just the net force on 3 will be simply F1 3x plus F2 3x along the I hat direction, and F1 3y, this guy here, minus this guy, and that will give me the j hat component. And that's it. So you just have to work out the numbers, and again, he's asking you to do that for the 6, for the other charge. I think for the negative 6 microcoulombs, which is this one. And again, you have to do the same thing, which is simpler. In this case, you have only one component from Q1, which is along the negative x I hat, and again you have to do it the same way with this one. This is going to be this way, so you'll have to add the 2 components along x and 1 component along y. All right, that's it. Second problem, which is a little bit longer, and we need to work out some few things. Here, let me just put this away. And again, so what you have to do, he wants you to find the electric field at point P. So he wants you to find the electric field at point P. And I wrote the net electric field as a vector is equal to the electric field due to Q1. Let me just, yeah, I call this Q1. So this is Q1, and the plus the electric field due to Q2, which I call that Q2, and the net or the electric field due to Q3, all as vectors. Okay, so what I have to do, I have to find each electric field by itself as a vector x along the x and along the y, and then I sum them up at the end. The one thing that I want to make a note of is that these distances between the charges, they are equal, and they are a over the square root of 2. This can be, you can find this several ways, realizing that these angles are all 45 degrees. This is 45, this is 45, this is 90, and this is 45, and that's 45. So you can work out that, but that's very easy. But as long as you know that these distances from the charges to the point P are the same, and they're defined by a over square root of 2. So let's find the again. So for the first one, I guess these are the givens. For charge number 1, the electric field is away, because all I have to do is place a positive test charge. If this is positive, this is positive, so it will be this way, away from the charge, or along the line away from the charge, and then it will have an x component and a y component. I have to find these components along the y, and remember this angle here is 45 degrees, so this is 45 and that's 45, all right? Okay, so again, the electric field due to charge 1, due to Q1, is defined by Coulomb's law, K Q1 divided by R1 squared and R hat, and I can find the magnitude if I want. So the electric field is defined in terms of these two components, and cosine to get the x component and sine the x component, and the angle has happened to be 45, so I can definitely pull the sine and cosine of 45 are equal. Okay, so you can work that out. I just put in the numbers. So Q1 is equal to 2Q, so I put in 2Q, and this is A over the square root of 2, so that's squared. When you square this, it will be 2. It will go up 4Q over A squared, and this is, sorry, I said 60, this is 45. This is, the angle here is 45. I apologize for that. The angle is 45. Here, let me just make sure that because this is cut and paste from the previous. So this is 45, and this is 45, and that's also 45. Okay, so that's my the electric field. So this is 45. So that's the electric field due to the charge that I called it same thing as this is 45. All right. Now the second thing I want to do, I want to find the electric field due to charge Q2, what I call Q2. Same thing. This is just to show you how you can get the area, the distance. Sorry. Here I fix the angle here. So again, I go through the same thing. The electric field is defined as KQ over R squared, and then it has two components, the x component and the y component, and cosine and sine, and the distance again is the same thing, A over the square root of 2. If I put them, remember this is Q. So if I put that, then it will be 2Q, right, over A squared, and sine, cosine 45 to get the x component, and I put in negative in both here to indicate that it's down in the negative direction. 45 that's E2. Similarly, I can do A3, sorry, the electric field due to charge, the third charge, which is this guy here. Now remember, this is negative, and so the electric field will be directed this way. So again, I have an x component along the positive and a y component along the negative, and if I do the same, follow the same procedure, I get this is my E3. All right. Now, what I want to do next is I want to add E1 or E due to Q1 plus E due to Q2 plus E due to Q3 as vectors, which I have the three of them here. So I add these guys here. Remember, this is not 60. Sorry, this is 45. Sorry. So this is 45, and then you just add up these guys you have two cosine, sine, and I. You can add these up very easily. All right, and you can work out the answer very easy. Okay. Now the last question, the last question, which he told you that you have four charges placed on the corner of a square of side A as shown in the figure. He wants you to find the electric field at this point right here. Okay, so how do I do that? Again, and then he wants you to find the net force. I changed this, by the way, it used to be 2Q, just so that make it simple, it's net force on Q. Okay, and you see why I want to do that. Okay, so the first thing that I wanted to know, what is this distance here, which is a squared plus a squared under the square root, so it will be a square root of 2. The first one, I wanted to find the electric field, the electric field due to charge 2Q. Okay, so this is the electric field due to charge 2Q, and this is positive, and I want to find the electric field here, so that means it's along the positive j hat. Okay, and that's what I have here. This is A due to charge 2Q, or the electric field due to charge EQ. And the same thing, E due to the charge, the 3Q charge. Again, this will be this way, directed this way, and along the I hat direction, and it's one component only. This one has only one component this way, and this one has only one component along the I hat. The electric field due to the 4Q charge is a little bit, we need to work it out. So it has, of course, 4Q divided by the distance squared, and then it has an X component and a Y component, and the angle again is 45. This is, these two guys are the same, so this has to be 45 and this has to be 45, and the angle of the electric field is 45. So these are the, and of course, if I work it out, it will be the cosine and the sine of 45 is plus a half. And yeah, so it's both of them positive. All right, when I add, all I need to do is just, of course, add these three guys. Okay, that means I add the I hat together. So this is 3. I'm just going to factor KQ square out. So that means 3 plus 2 over square root of 2. That's along the I hat. And then along the j hat, I have 2, and then I have 1 over the square root of 2, or sorry, 2 over the square root of 2, and you can work that out and find the net electric field, the magnitude and the direction of the net electric field. Okay, now part B, I want the net force on Q. By definition, F net is simply Q times the net electric field, and you have the net electric field, so you simply multiply it, and you get the answer. Okay, that's all, and best of luck. I'll see you inshallah on Tuesday. Thank you very much. Bye.